And here we have our next topic, which is integration by parts. And basically, if you remember this formula really well, you will do great on this kind of questions. So I'm gonna explain how this function was derived, and let's take a look. You have probably learned how to use product rule already, so I don't want to further explain that. And what I'm going to do here is to take the integral of the product rule. And on the left side, you can see the integral of the derivative of fxgx is just fxgx. And on the right, we have the integral of f prime x times gx dx plus the integral of fx g prime x dx. And we're trying to find this part, so we're gonna isolate it. So what I'm going to do is just minus the integral of f prime x gx dx by both sides, and then we ended up with the formula for integration by parts. That's really easy, right? And for the equation I wrote previously, I just said u equals to fx and v equals to gx, so don't get confused. Here I have 3 examples, and I'm going to do each of them so you guys can understand integration by parts more deeply. And for you guys, I'm gonna rip off my previous page just in case if you forgot the formula already, and I'm gonna put it on top of the video. By looking at the formula, we know that x and cosine x equals to u and dv by its position. And since u equals to x, we know that du equals to 1. And since dv equals to cosine x, the integral of dv, which is v, equals to sine x. So all we have to do right now is plug in all the u, du, v, and dv according to the formula. So the integral of x cosine x dx according to the formula is x times sine x minus the integral of v du, which is sine x times 1. And that equals to x sine x minus negative cosine x. And since we have a double minus, which makes it a plus, so we ended up with x sine x plus cosine x plus c. Sorry, I forgot. And that will be our final answers. Let's move on. Here we have the integral of ln x times dx. And just follow the formula. We're gonna write out our u, dv, v, and du's. So u equals to ln x, so du will equals to 1 over x. And we don't have a dv here, so that will be 1. Since dv equals to 1, the integral of dv will be x. So let's plug in the numbers. So according to the formula, we have x times ln x. Sorry, I didn't write x, I forgot, but I'll put it later. Minus the integral of x times 1 over x dx. Since x times 1 over x, the x canceled out, and we have the integral of 1, which is equals to x. So our final answers should be x ln x minus x plus c. And that will be our final answers. Alright, we have our final examples. So we have the integrals of x squared times e to the x times dx. So again, according to the formulas, we can set u equals to x squared, and then du will be 2x, and then e to the x is our dv. So the integral of e to the x is still e to the x, so v equals to e to the x. And right now, we're gonna write our new equations according to the formula. So we have x squared times e to the x minus the integral of e to the x times 2x dx. This question is a little bit more complicated than the other ones, because you see we cannot like directly calculated integrals of e to the x times 2x. So later we have to use the integration by parts formula again, but right now we're gonna take the constant out and it leaves us with the integral x times e to the x. And okay, again, we're gonna redo the integration by parts on the integral of x times e to the x dx. So for this integral, the u will equals to x and du will be equals to 1, and dv is just e to the x, and the integral of e to the x is just e to the x. So rewrite the integrals according to the formulas. We have x times e to the x minus the integral of e to the x, and the integral of that is just e to the x. And now this is the integral of x times e to the x dx. So we can plug that in back into our original equation. And now we have x times e to the x minus 2 times x times e to the x minus e to the x. And then we have to plus c at the end. And get rid of the parentheses. That will leave us the final answers. So this is the end of this chapter. I hope you guys learned something, and please ask your teacher or Mr. Todd if you have any questions. And now we're heading to our last chapter, which is partial fraction. I put this at the end because I felt like this chapter is the easiest among all three I have taught today. It will seem complicated the first time you've seen them, but trust me, the more you practice them and if you truly understand how it works, it will only get easier and easier. So here we have an integrals that has a denominator of a polynomials that can be separated. So here I'm gonna rewrite the denominator. So if you can do algebra, you know that x squared minus 4x minus 5 is equivalent to x minus 5 times x plus 1. So what I'm going to do now, I'm gonna separate the denominator, and I'm gonna have a variable of a and b on the numerator, and you see a over x minus 5 plus b over x plus 1, and you should probably know that this whole thing will equals to 3x minus 8. What are we really trying to find is the value of a and b, so we can take the integral of the whole thing. So now I'm gonna write out some equations. So we can say that 3x minus 8 equals to a times the denominator of b, which is x plus 1, and plus b times the denominator of a, which is x minus 5. And get rid of the parentheses. We have 3x minus 8 equals to ax plus a plus bx minus 5b. Now it's time for us to solve for the values of a and b. By looking at this equation, we can know that ax plus bx must equals to 3x, because these are the only three variables that have x's in it. So we're going to write that ax plus bx equals to 3x, and we can cancel out the x's. And also we have a and b, so we can write that a minus 5b must equals to negative 8. And now we have two equations of a and b, so we can plus or minus two of the equations to cancel out one of the variables. So what I'm doing here is I'm gonna minus subtract equation 2 from equation 1, and we ended up with 6b equals 11, and b will equals to 11 over 6. And since we know the values of b, we can just plug that in to the equations of a plus b equals 3, so we can solve for the value of a. And a is equals to 3 minus 11 over 6, and that gives us 7 over 6. Once we determine the values of a and b, we can just plug that in back into the integrals, where we have a over x minus 5 plus b over x plus 1. So a equals to 7 over 6. So we can have 7 over 6 times x minus 5 plus 11 over 6 times x plus 1. And then we take the integral of this. We got 7 over 6 times ln absolute value of x minus 5 plus 11 over 6 times ln absolute value of x plus 1 plus c. And that will be our final answers. So if you have any questions, please ask your teachers for help or Mr. Ta, because he's the magician. And I highly suggest you guys to watch Khan Academy's videos to review for all your tests. And you might see some similar contents to compared to my videos, because I watched their videos before I make this video. So thank you guys for watching. Do well on your finals.